Hello students, today we're actually learning about modeling in science. And by the way, this is actually the part 2 of the change of states we're learning in the last lesson, okay? And so this modeling is going to actually put everything together and make us understand the importance of modeling, okay? Now, before we begin, what I want you to ensure is that you've got all your equipment with you, okay? I've got your pen, I've got your pencil, I've got your ruler. So I'll need you to pause the video now, gather everything together, including your green pen, and when everything is sorted out and ready, click on play to begin. Okay, so your learning objective is to understand the importance of modeling in science, okay? So again, I would like you to pause the video and actually write it down. Okay, let's move on. Now, based on what we've learned from last lesson, I want you to look at this, okay? This is a football pitch. It looks like maybe they're Liverpool fans or Man United fans. I'm not too sure, okay? But what do you think the following represents, okay? The football players, the crowd when they leave at the end, okay? Now, a clue is based on what we've been learning in the last lesson. So the states of matter, solid, liquid, and gas. Which one represents what? So I'm going to give you around 30 seconds to think about it, pause the video, write it down, okay? And then play when you're ready. Okay, now the football players, okay, now they've got enough space for them to move around. They're literally moving around, okay? So that can actually represent the gas state, okay? They've got more than enough space. Now, when we look at the crowd, you can see the crowd are actually sitting down next to each other, okay? The fact that they're sitting down next to each other, they can't really move at that position. That actually represents a solid state of matter, okay? And the third one says when the crowd are leaving at the end of the football match. Okay. Now, when they stand up and moving, there's still not enough space, but they're still kind of moving. That would actually represent the liquid state of matter. I do hope you got that right. If you didn't, that's fine. Just make sure you make that correction using your green pen, okay? All right, let's move on. Now, today we should be able to understand how important modeling is in science and how it actually helps us to understand things we cannot see, okay? And to secure this knowledge, what I would like you to do will be to actually find a way to differentiate between 2D and 3D. And this will be based on a discussion either in your class or in your Zoom lesson, or actually send an email to me telling me about some of the things you understood from it. And then to master this knowledge, hopefully you should be able to evaluate advantages and disadvantages of different types of modeling, okay? So we'll be doing this through using things like Venn diagrams and again discussion that can be done in your Zoom lesson or in the actual classroom, okay? Now, here's an activity I want you to do, okay? Based on your knowledge so far, okay, we're gonna start straight away modeling this, okay? I want you to actually create, okay, a model of a solid, a liquid, and a gas. Using, it doesn't matter the size of the paper. You could do a free A3 paper, A4 paper, but you could literally draw it like a circle using like a marker pen or a pen, and then get a paper, tear it into pieces, and actually form what or model what solid looks like, what liquid looks like, and gas. Guys, children, you can literally be very creative with it, okay? You can use different colors to represent it, even amazing. And what you can do after doing that is, I would like you to actually take a picture of this and actually email the science department. And the best drawings are going to be getting some achievement points and some letter home to tell your parents how brilliant you've been, okay? So this is an activity for you to do, okay? So you can pause the video and carry out this activity and continue, or you can do that at the very end. But I want to definitely see what you've done. Now, moving on, okay? So this is how it should look like from the last lesson, okay? See, solid, as you can see, the atoms, the particles are quite close to each other, and they vibrate. They're kind of fixed, in a fixed position. They're not really moving, okay? Just as the spectators, the crowd watching the football match, they're all sat down, okay, tightly close to each other, and they can't really move around, okay? They can only vibrate, okay? And if you look at liquid as well, there's a bit of space, yet they're still close to each other, and there's a bit of moving around, but not as much, okay? And it's random as well. It's a bit random, okay, in terms of the arrangement of the particles. But when it comes to solid, it's very regular. As you can see, it's much more patterned, if you're making sense. And if we look at gas, okay, as you can see, there's a lot more space, and this is random, and they're far apart. So the particles can actually move quickly in all directions, okay, compared to liquid and compared to solid. So the question now is asking you, what do you think this is not showing properly? Okay, this particular model we've done, the diagram of particles, what is it not showing us? And that is something I want you to think about, and that is something we're going to be answering together. Now, question, what are the advantages of actually using models? Okay, and this is what we're going to be looking at. Now, what we're going to do now is I'm going to list a couple of things, okay? First of all, they show particles are arranged, which is good. They show that particles are close together in a solid state, in a liquid, or in a gaseous state, okay? They do show that particles are arranged in regular form in solid, which is something we cannot see unless we actually model it, if that makes sense. And that is how we get to understand things like this as scientists. They show that there is no room between particles in solid and liquid to compress them, if that are making sense. Okay, and number 5, it also shows that particles are close to each other in liquid in compared to gas, and they show that particles are not in a regular pattern in liquid, and lastly, they show the particles are far apart in a gas. Now, you don't need to really write much of this, okay, but make some short-term notes, some summary. And lastly, they show the particles are not arranged in a regular way in a gas, okay? Now, that's basically we understanding the importance of modeling, because modeling, basically, like it says, it allows us to actually see things we cannot really visualize in our heads, if that makes sense. Now, 2D and 3D, okay? You go to the cinema, you sit down, you wear the 3D glasses, and it feels like the movie is actually coming out of the screen. That's how it feels in 3D. So 3D is meant to give us, it's like 3-dimensional for us to see things like it's actually outside, okay? And this is actually what is showing there, okay? As you can see, this is a 2D, a picture of what a 2D is like, a cartoon version. It's flat, okay? And 3D is like, wow, it's out. It's like, it's something that you can see, like almost you can hold, okay? And if you look at that particular image as well, you can see that's a flat image. And if you look at the second one, you can see that is much more 3D. It's more dimension. You can literally see the shade of everything. It makes it look really round and real, okay? And that is the same thing with this particular model and Mario as well, as you can see. And as you can see, things have also actually evolved over time. Back when I was really young, okay, we used to watch a lot of things in 2D. Cartoons were in 2D, but these days cartoons are actually in almost 3D form, and it looks like it's so real, okay, which is quite interesting. And that is the modern animation that we see today. Now, 2D dimensional, that is a 2D dimensional representing gas, okay, believe it or not. And this is a 3D dimensional of representing gas as well. Now, this is quite interesting, okay? And now this is when we're going to start thinking about, okay, what is the advantage of this, okay? What are the advantage and disadvantage? And what I'm going to ask you to do next is to write down some list of things. And we're going to be drawing a Venn diagram to explain this further, okay? Now, we've been able to secure that knowledge. Now we should know the difference between what a 2D and a 3D model looks like, okay? Now, for our Venn diagram, what I would like you to do first is to actually draw this Venn diagram, okay? And label it 2D, all models, and 3D, okay? We're going to be talking about it, okay? Some of these advantages and disadvantages. Now, I would like you to draw it big, because what I'm going to ask you to do next is an activity of writing and sticking these things in, okay? So again, pause the video and make sure you draw it, probably in a landscape format, okay? Okay, now this is the thing. Okay, I'm going to be listing things. Okay, one, you need to write this down in a piece of paper and actually tear the paper. Okay, and then what you're going to be doing is you're going to be placing it in the Venn diagram, whether this is representing the 2D module, representing the 3D module, or it represents all module, this particular statement. Okay, so the first one, they do not show how particles are moving. Is that representing the 2D, the 3D, or all module? Okay, the second one is saying all modules, well, the modules don't show how the particles are arranged in 3D. Is that for all modules? Is that in 2D or 3D? The particles in the gas are too big and too close together. Okay, where can you visualize that? Can you visualize that in 2D or 3D? Again, the particles in gas looks too big and too close to each other. Okay, now modules are more difficult to create. Okay, modules are very easy to draw. Okay, so what I would like you to do now, oops, I almost showed every answer, is to actually write this down, write this statement, and your Venn diagram, I would like you to actually place those words or write those words if it makes it easier in between that. Okay, so I'll give you a couple of minutes to actually do that. So again, pause the video and do it. All right, let's look at the answers together. Okay, now, first of all, for 2D, the modules don't show how the particles are arranged in 3D, obviously, because it's in 2D, okay? It's drawn in 2D, so you can't literally visualize how it is in 3D. Another thing that represents, the statement that represents the 2D modules is, modules are easy to draw. Yes, because it's just a flat shape you're drawing. You're drawing probably a circle or a square, and it's very, very easy to draw, okay? Now, when you look at the statement that represents all modules, they do not show how the particles are moving. True. Whenever you draw them, it's just stand still. It's not going to be moving right in front of your eyes, okay? So none of them show how the particles are moving or where they're moving. Also, the particles in the gas are too big and too close to each other, okay? As you can see in the last 2 slides, I showed you about how big some of this 3D modules is in, okay? So it's so hard to visualize how the closeness of it together, okay? Because why? In the gas particle are too big and too close to each other, if I'm making sense, both for 2D and 3D module. So that is very important to understand. For 3D module, okay, the modules are more difficult to create, okay, which is very true. And also it's easier to visualize the shapes of the solid. Now that is an advantage because you can easily visualize it as well, if I'm making sense. Okay, so I do hope you've gotten your mark. If you didn't get full marks, that is fine. Again, just make sure you pause the video and make your corrections as well, which is very, very important. All right, now let's look at this together. Okay, this is one of the last activities we're doing. Which of this is right is the question. A, particles module show how particles are arranged in solid, liquid, and gas. B, particle module show how particles can move. Particles are always good at showing how far apart the particles are. And D, 2D modules are easier to draw than 3D modules. So take some time, look at them, which statements are right. Is it number 1, number 2, number 3, number 4, number 5? Have a look. All right, now your answer is actually A and D, because why? Particle modules do not show how particles move, and particle modules are not always good at showing how far apart particles are. That is actually the disadvantage of it. Instead, particles show how particles are arranged in solid, liquid, and gas, and 2D modules are easier to draw than 3D modules. Okay, again, pause the video and mark your work. Now, what we've been able to do is to actually secure this knowledge, and I do hope you've understood it. It will be interesting for you to send us an email and give us a summary of what you've learned so far, and we're going to be talking about more of this in the next video. Bye bye.